I am Dr. B.J.D. Kalyani, working as Associate Professor in the Department of Computer Science and Engineering of Institute of Aeronautical Engineering. In this video, I will discuss about mode of data transfer. The mode of data transfer is related to the input-output subsystem of computer organization. At the end of this video, the student will gain knowledge regarding what are various methods of mode of data transfer, how the computer system can collect data from the input devices, how they can be represented, and how the data transfer can take place between computer and peripheral devices. That can be the main concept of this video. And the major agenda of this video is introduction, the types of data transfer, what is programmed I/O, what is interrupt initiated I/O, and DMA. The computer can have interaction with the outside world by using the peripheral devices. The input devices generally provide man-to-machine interaction. To perform the program, the intended functionality, some data can be required. This data can be supplied by using variety of input devices. The output device can collect the processed information from the computer and can be represented in an user understandable form with the help of output devices. Thereby, the output devices can provide the interaction between machine to man. So, both the input and output devices combinedly can be referred as the peripheral devices. So, the method that is used to transfer information between internal storage and external I/O devices is called the I/O interface. So, here in the internal memory, the data can be stored. So, how it can be received from the external input devices and how it can be represented in an user understandable form via the output devices. That is known as the I/O interface. The CPU is interfaced using special communication links by the peripheral connected to any computer system. So each peripheral device can employ an interface that can be connected to the system bus, which in turn connect to the CPU and memory to read and write the information from the memory. These communication links are used to resolve the differences between CPU and peripheral devices. So the interface can be required between peripheral devices and the internal storage of the computer. So here, why the interface is required means the internal components of the computer can operate and transfer the data at a very high speed, but the peripheral devices is of low speed. So to synchronize the speeds, interface can be required. And the internal data representation formats can be different from the input-output device formats. To gain the commonality between the data formats, the interface can be required. Not only that, here the internal part of the computers are the electronic devices, but generally the peripheral devices are electromagnetic or electromechanical devices. So, to synchronize all these, the interface can be needed for the peripheral devices. So, here to mitigate all these and to resolve these differences, a communication links can be used for the I/O interface. There exists a special hardware components between CPU and peripherals to supervise and synchronize all the input-output transfers that are called the interface units. How the I/O module can receive the information. So this is the I/O logic and variety of external device interface logics can be connected via the interface devices. For each and every external device interface logic can have three communication lines. One is the data communication line, which can carry the actual data for read and write operation. Control is used to carry the control signals to indicate what operation to be performed, either read or write. Status is to indicate whether to represent and to test various status of the I/O transfer. So here data register can hold the data. Status and control register can hold various status flags. So these can be connected to the internal system bus via the address lines, control lines. The address lines can carry the memory location where from the data can be read or written to the memory. So the I/O module must take the decisions regarding whether to hide or reveal device properties to CPU. So each and every device can have a device interface, generally with a software. Familiar interfaces are the device drivers, so that the newly connected device can be synced with the internal storage of the computer by using these softwares. And the I/O module next decision is to support multiple or single devices. A single device driver routine can be used for multiple device management, or a separate software can be required as an interface for the modules. The next I/O module decision is control device functions are leave for CPU. So here the status and control flags, how they has to be set and reset according to the status of the I/O module. And also operating system decisions, like for example, if you consider the Linux or Unix operating system, they can consider the peripheral devices as a file. So here, what are the operating system treatment regarding the peripheral devices that can be considered during the I/O module data transfer? What is mode of transfer? The binary information that is received from an external device is usually stored in the memory unit. The memory unit can be used generally to store user programs as well as data. So whatever binary information that is captured by using the input devices and can be used to represent via the output devices can be stored in the memory unit. The information that is transmitted from CPU to external device is originated from the memory unit. So with the help of memory unit only, the data that can be transmitted for the input unit as well as for output unit can be originated. So here memory unit can support two basic operations, that is read and write operation. Whenever read operation is applied on the memory, the data from the memory unit that is pointed by the address register, from that address the content of the memory can be retrieved to the data register. In case of memory write, the data register content can be transferred to the memory location that is represented with the help of address register. So CPU merely processes the information, but the source and target is always the memory unit. The data destination can be the memory unit, which can facilitate either the read or write operation. So the data transfer between CPU and I/O devices may be done in different formats. So this transfer can involve various methodologies. They can be majorly divided into three. The three types of data mode of transfers are programmed I/O, interrupt initiated I/O, direct memory access. What is programmed I/O? So it is due to the result of IO instruction that is written in computer program. So whenever the program is executed, the instruction that is pertaining to the IO operations is referred as IO instruction. So here the programmed IO, the input output operation can be initiated with the instruction that is stored in the program. Each data item transfer is initiated by an instruction in the program. For example, if you consider the C language, the input-output operation instructions are generally written using the scanf and printf state functions. So, whenever a program encountered this, the input-output peripheral devices can be activated. So, with the help of the program instruction, the input output operation can be originated, then it is referred as the programmed IO. Usually the transfer is from CPU register and the memory. In this case, it requires constant monitoring by the CPU of the peripheral devices. So when the input can be completed and how it can be controlled can be continuously monitored by the CPU in case of programmed IO. The second method is interrupt initiated IO. So by using interrupt facility, special commands to inform the interface to issue an interrupt request signal whenever data is available from any device. So whenever data is available, the interface can raise an interrupt signal so that the CPU can temporarily suspend the current program execution and can service for the device for the input-output operation. So here, by raising of the interrupt signal, the service that is requested for the input-output device can be done. So that's why this type of data transfer mode is referred as interrupt initiated IO. So in the meantime, the CPU can provide for any other program execution. The interface meanwhile keeps monitoring the device. So the IO interface can monitor the IO operation, its completion, the controlling, the monitoring can be done by the interface. In the meanwhile, the CPU can execute the program. So, but in the previous case, if at all an IO instruction that originates the IO transfer from the program instruction, programmed IO, the CPU must continuously monitor regarding the status of the input-output operation. But in case of interrupt initiated IO, the IO interface can look and monitor the IO operation completion and the CPU can continue the program execution. So when it is determined that the device is ready for data transfer, it initiates an interrupt request signal to the computer. So whenever a interrupt signal is detected, CPU stops the task that is currently executing, branches to the service program to process the IO transfer, and then return to the task it was originally performing. So this method of data transfer is referred as interrupt initiated IO. And the third method is direct memory access. So the data transfer between fast storage media such as magnetic disk and memory unit is limited by the speed of the CPU. So to mitigate this problem, allow the peripheral devices that can directly communicate with each other using memory buses. So removing the intervention of CPU while the input-output data transfer. So directly the peripheral devices can communicate with the memory via the buses. That type of data transfer is direct memory access. So this type of data transfer technique is referred as DMA or direct memory access. During DMA, the CPU is idle and it has no control over the memory buses. Directly, the data transfer can exist between peripheral devices and the memory unit. So that method of data transfer is the DMA. These are the three modes of data transfer. Now we'll look into each and every method of data transfer in detail. So here the data transfer from IO devices to CPU is generally done with the help of the hardware implementation. So here whenever status register, the flag bit is looked and monitored by the CPU. So if it all the data is kept on the data register, the flag bit can be set so that the data is readily available, so the IO bus can carry out the input-output operation, and it can carry out input-output operation by disabling data accept signal, so that the input-output operation can transfer the data from IO devices to the CPU via the address and data buses according to the read or write operation. So in this way, the status register flag is useful to check whether data is placed in the ready in the data register or not. So a program is written for a computer to check the flag of the status register to determine if a byte has been placed in the data register by the IO device. If it all the data is ready in the data register, then only the flag can be high. So a computer program can be required which continuously monitor the flag of the status register to determine whether data is ready in the data register or not. If the flag bit is set, the CPU reads data from the data register. Then only if it is F is equal to 1, then only from the data register to the CPU the data can be transmitted. If the flag bit is cleared, the interface disabled the data acceptance line and the device can then transfer the next byte. In this way, the data transfer can be exist. So here the important role is a program is needed to check the flag bit of the status register. So how the input has to be taken by with the help of this program can be represented as a flow chart. So here read status register, check the flag bit. Depending upon the flag bit value only, the data transfer can be take place. If flag is 1, read data register, transfer data to the memory. Whether the operation is completed or not, we have to check, and if it is operation is completed, continue with the program. Otherwise, it has to go step 1 and repeat that step. If flag is 0, disable the data acceptance line. So in this way, the CPU can check the status register flag bit whether data is readily available for data register for IO operation. So in the programmed IO method, CPU stays in the program loop until IO unit indicate that it is ready for data transfer. Continuous checking and monitor can be required. So this is a time consuming process. So the processor is busy for checking the flag register value. So this method is particularly useful for small and low speed computers, but here most of the CPU time is wasted for checking of the data availability of the data register. So to mitigate this, the second method, interrupt initiated IO, can be used. So here an alternative to CPU constantly monitoring the flag to let the interface inform computer when it is ready to transfer the data. Here the CPU is in the programmed IO continuously monitoring the status register flag bit value. That's why the CPU time can get wasted. To avoid this, the second method, interrupt initiated IO, can be used. In this, when the data is ready, the interface can inform the CPU via the interrupt signal. So this mode of transfer uses interrupt facility. So interrupt is a signal that can be raised to the CPU to gain the service for that particular device. When a flag is set, the computer is momentarily interrupted from proceeding with the current program and is informed of the fact that flag has been set. So in this case, if the status register flag is set, automatically interrupt can be raised by the IO interface to the CPU so that the CPU can be involved in the IO transfer. The CPU deviates from what is doing to take care and it has to majorly involve in the input-output transfer. So this method of data transfer is called interrupt-initiated IO. So here, what is vectored interrupt? So CPU responds to the interrupt signal by storing the return address from the program counter into the memory stack. So whenever an interrupt signal is detected by the CPU, for example, the CPU currently executing a main program, and in the meanwhile, the IO operation, one peripheral can require the IO operation. The data is readily available, status register flag is set so that the device can raise and interrupt the signal that is raised interrupt here while executing the main program. Thereby, the CPU stops execution of this main program and transferred to the ISR interrupt service routine, that is the peripheral IO operation. So as soon as completion of this input-output operation, it must return to the main program and resume the execution of the main program, so that before traversing to the control from main program to the interrupt service routine, the return address can be pushed to the stack so that whenever the completion of IO operation, by popping the return address from the stack pointer, the main program execution can be resumed. So here there is a need to store the program counter address to a memory stack for service the interrupt. There are two methods to store these return addresses. One is vectored, second one is non-vectored. In a vectored interrupt, the source that interrupts supplies the bank information to the computer. So this information is called interrupt vector. So what is the peripheral device that raises the interrupt that supplies the bank information to the computer? So this method is called the interrupt vector. Generally, interrupt vector is the first address of the IO service routine, so that it can be easily detected and fetched the return address to resume the main program execution whenever an interrupt can be happened. So that is generally referred as vectored interrupt. What are IO routines? So software routines for controlling peripherals and the transfer of data between the processor and peripherals is referred as the IO routines. So the software that can facilitate input-output operation between processor and the peripheral devices is referred as IO routines. IO routines for standard peripherals are provided by manufacturer. So those generally we can call it as device drivers. Whenever a new device is connected with the CPU, the particular device driver can be installed so that the device can actively transfer data between CPU and that peripheral device. IO routines are usually included within the operating system. IO routines are usually available as operating system procedure in the BIOS function call. These procedures can be stored. So with the help of these software routines, the peripheral I/O operation and the data transfer between peripheral devices and CPU can be controlled. What is priority interrupt? So in the interrupt initiated I/O, the device which require the input-output operation can raise the interrupt signal for the to gain the attention of CPU for the service. So when two devices can raise the interrupt at the same time, which interrupt can be considered? That is called the priority interrupt. Identify the source of the interrupt when several sources will request the service simultaneously. So multiple devices request the CPU service by using the interrupt. The priority interrupt concept can be come into picture to decide which device can have the highest priority. So determine which condition is to be serviced first when two or more requests arrive simultaneously. So there are two methods. One is by using the software, second one is by using the hardware. With the help of software, polling is the method for deciding the priority of the interrupt. By using the hardware, daisy chain and parallel priority are the methods for deciding the priority interrupt. What is polling? Polling is the software method of priority interrupt. So identifying the highest priority source with the help of software means is called the polling. One common branch address is used for the all interrupts. Okay. Program polls the interrupt sources in a sequence. The highest priority source tested first. So if there are many interrupt sources, the time required to poll them can exceed the time available to service the I/O device. So multiple interrupts can be raised simultaneously by the device. With the help of software, the polling software, the computer can decide which device can be polled first depending upon the time the interrupt is placed. And also a polling program, the software can poll the interrupt sources in a sequence. How this polling can be done? So here, whenever multiple interrupts are raised, the polling software can poll each and every device. Whether the device is ready for the data transfer or not, each and every peripheral that is connected can be polled. Are you ready? The device is not ready here. Here also not ready. Not ready. Here the device is ready. So this device can gain the highest priority and can be served first. So with the help of software means the polls can be done and a common written address, branch address can be maintained in the case of polling. So in this method, when the processor detects an interrupt, it branches to the interrupt service routine whose job is to pull each I/O module to determine which module caused the interrupt. So here, with the help of this polling software, which module or the I/O device can poll the interrupt can be detected. So the poll could be in the form of separate commands line. Okay. So to testing the I/O command signals can be done poll to each and every device. In this case, the processor raises the test I/O, places the address of particular I/O module on the address line. It has the interrupt, that is, the interrupt is identified in it, and it is the order in which they are tested, the order in which they are appear on the address line. In a sequence, the poll software can poll each and every device with the help of test I/O signal. As while testing, highest priority sources are tested first, then the lowest priority devices. This is a simple method of establishing priority on simultaneous interrupt, but having a disadvantage that very time consuming. Poll each and every peripheral devices is a time consuming task. So this is the software means how the priority interrupt can be serviced. The second one, by means of hardware, how the priority interrupt can be decided is the daisy chaining. The daisy chaining method of establishing priority consists of serial connection of all devices that request an interrupt. So, the peripheral devices can be connected in a sequence to that request the interrupt. The device with highest priority is placed in the first position, followed by lowest priority devices up to until the lowest one. So here the connection of daisy chaining is like this. So here device 1, device 2, device 3. So here interrupt input, priority interrupt output. And these devices can be connected in a serial. So here if the second device is raised the interrupt and having the highest priority, it can be serviced. So here it has to be serviced by the CPU, the second device, and it can disable the next devices with the 0 to indicate that CPU is servicing that particular device which is having the highest priority. So this is the daisy chaining method. So one stage of daisy chaining can has to evaluate invalid, that is interrupt is requested but no acknowledgement, and no interrupt request pass to other devices and interrupt request. So here to indicate this one stage of daisy chaining, this is the internal circuit, and here PI and PO are the interrupt request. The priority in request can has to be given to each and every device, and here the RF and PI, depending on that, the PO can be set. During first case, no valid interrupt can be taken place. In the second case, invalid, that is interrupt is requested but no acknowledged. So in case of 01, interrupt is requested and no acknowledgement. In case of third case, no interrupt request passed to the other devices. In the fourth case only, the interrupt service routine can be serviced to that particular device. What is the difference between the programmed I/O and the interrupt initiated or driven I/O? In a programmed I/O, processor has to check each and every I/O device in a sequence. Okay, whether the data is ready on the data register by checking the status register flag bit. But in case of interrupt driven I/O, the data is ready. Momentarily, the interrupt can be raised by that particular device to gain the service of the CPU. The second difference is during polling process is busy and they have serious and decremental effect on the system throughput. So continuous monitoring of CPU is required in programmed I/O so that the throughput can be decreased in case of programmed I/O. But in case of interrupt driven I/O, with the interrupt only, the interface that requires service can request the CPU so that the throughput can be increased. It is implemented without interrupt hardware support, but here interrupt hardware support can be required. With the help of interrupt only, the I/O service can be done in case. So special mechanism can be required for the interrupt driven I/O. But in case of programmed I/O, it does not depend on interrupt status, but interrupt driven I/O can be depending upon the interrupt status. The next difference is programmed I/O need not initialization of stack, but here initialization of stack can be required in order to store the return address of the interrupt service routine. System throughput decreases as number of I/O devices connected in the system increases in case of programmed I/O. But in case of interrupt driven I/O, system throughput does not depend on the number of I/O devices connected in the system. So these are the major differences between programmed I/O and interrupt-driven I/O. The third method of data transfer is direct memory access. So here the CPU intervention is minimized and null interfered. Directly the peripheral devices can be communicated with the memory in case of direct memory access. So it involves a transfer of data between I/O devices and memory by external circuitry system called DMA controller. With the help of DMA controller, without involving the microprocessor intervention, the I/O devices can communicate directly with the memory. So how this DMA controller, how the communication take place, we will see in the next video. So in this, the major modes of data transfer, one is the programmed I/O, second one is interrupt initiated I/O, third one is DMA. How the programmed initiated I/O can be worked and how interrupt initiated I/O can be worked. In case of multiple interrupt priority can be checked with the help of software by using the polling method, with the help of hardware by using the daisy chaining. Okay, thank you.
Like, share and subscribe. Hit the bell icon for more updates.